Welcome to Module 7. So Module 7, the title is probability. Well, probability basically means what is a chance. So the probability theory is the study of random events. That's really the definition of probability. In probability, there are a few things you need to know. How we describe a probability using the formula. So to do so, let's look at an example. What is the chance, say, a probability of pulling an ace from a well-shuffled deck? What would you say? You probably say it's 4 out of 52. So how do you calculate that? So let's express the probability in the formula. So P of A is equal to the fraction on the top is the number of desired events over the bottom number of all possible events. So the desired events in this case is the ace card, and there are 4 of them, so the number 4 goes on the top. And the number of possible events, meaning the number of all possible cards, in this case would be 52, so it will be 4 out of 52. So what's this P? Well, P is short for probability, so wherever you see the P in the statistics, that means you're probably asked to do probability. This A, it's called a random variable, and it's typically, it's always going to be a capital letter. When it's a capital letter, it's a random variable. It's similar to the variable in algebra, where it represents a number. In statistics, A represents what we call the event. So in this case, instead of writing ace card, we just say assign A to mean the ace card. So that means P of A in this problem means the probability of pulling an ace card. There are 4 ace cards, and then there are 52 cards total. So the P of A will be 4 out of 52, which will reduce to 1 over 13. If you do the math using the calculator or Excel, you get 0.07692, which is about 7.7%. So a few other words you probably should know. Outcomes are these are the most basic possible events. An event is an outcome of some kind of action. So for example, pulling one card of a deck is an event. So P again is probability. A represents the random variable. So the P of A represents probability of event A happening, whatever the A happens to be. Okay, so probability ranges from 0 to 1 or 0 to 100%. So if you get a probability that's over 1 or 100% or a negative probability, you're probably doing something wrong. So that's a quick tip there. So there are a few different types of probabilities. So I'll go through one by one. So let's look at the M&Ms. So the first rule I'm going to explain to you is multiplication rule, or it's called the AND probabilities. Okay. So say you're M&M junkie. You love both the plain chocolate and peanut butter M&Ms. You also love to mix the two types in a bag. So you do that and assume you have a bag of M&Ms as follows. So there are 39 chocolate M&Ms in the bag and then 61 peanut butter. And the colors are blue, red, yellow, and brown. So 11 blue ones, 27 red ones, 38 yellow ones, and then 24 brown ones. So in total, they're both 100. So these are the types, and these are the colors. So I'm going to look at both the type and the color in this problem. So what is the probability that if you randomly pick one M&M, it's going to be a blue chocolate piece, or you could say blue and chocolate piece. So that's where the and comes from. In this case, you use the multiplication rule. So let's assign A to be chocolate and B to be blue. So in this case, probability of it picking a chocolate M&M will be 39 out of 100. 39 out of 100. And the probability of picking a blue M&M will be 11 out of 100. So you calculate two separate probabilities separately. What you do is in the multiplication rule, you multiply the two probabilities. So in this case, 39 over 100 times 11 over 100, which comes out to be 429 over 10,000. And you can leave it as a fraction, or you can calculate the decimal. So 429 divided by 10,000. Whatever that is, that's your probability for getting a blue and chocolate or blue chocolate M&M. You know the problem is the and probability, or to use the multiplication rule, because it will say so in the problem. If the problem is and or implied and, then it's an and probability. The other one is the either or probability, or just simply or probability. So let me ask you a new question. What is the probability that it's going to be a blue or chocolate? So just reading this problem, I know this is going to be an or problem because there's a word or in there. So that's the difference between the and or. Or is pretty explicit. So again, the same thing. A is chocolate, B is blue. So we calculated these already. So P of A will be 39 over 100, and then P of B will be 11 over 100. The formula for the either or probability or the or probability is that you add individual probabilities, so P of A plus P of B minus P of A and B. This upside down U sign is the same as saying and, which I skipped over here, but it's and here and here. So that means you add the P of A plus P of B minus P of A and B. And this U looking sign is the OR sign. So in this case, 39 over 100 plus 11 over 100, same as before, minus what we just calculated above, 39 over 100 times 11 over 100. And if you multiply these out, you get 4571 over 10,000. And again, you can leave it as a fraction or change it to a decimal. Notice that this is an and multiplication rule, and it's the same thing as the one before. Okay. There are two types of events, independent ones and dependent events. So the independent events do not affect the probability of each event, so each event is separate. They're independent with each other. And then dependent ones, on the other hand, do affect the probability of each event. So each event is depending on what happens before or after. So how do you know which one the sequence of events are? The sequence of events is dependent or independent. Quick rule is that it's independent if whatever you pick is being replaced. So independent events are with replacement. So if you pull a card out, before you pull the next one out, you put the card back in. That's with replacement. So that would be independent event. Dependent, on the other hand, is that you do not do the replacement, so no replacement or without replacement. So in this case, let's say you pull out the first card and then don't put it back in, you just put it aside and pull the second card. That sequence becomes dependent events. Okay. So here's a question. Assume you pick 4 M&Ms in a row. What is the chance that you get 4 yellow ones in a row? So this is assuming I'm not going to be replacing the whatever I pull out. So this is considered to be dependent events. And the probability for dependent events is you calculate as follows. So there are 38 M&Ms for the first pick. So 30 out of 100. Assuming that is the yellow, there are only 37 left. But then since I'm not replacing the one that I just picked, so the bottom number would be 99. So 36 and 98, 35 and 97, and so forth. So what you do is you multiply all these out, and you get 0.0188245. So it's about 2% chance that I get 4 yellows in a row. Again, these are dependent events. Okay. So into statistics, we cannot go on without talking about the counting methods. So in any problems, if you see the question, how many are there, or how many ways, or how many of these, this and that, that is a clue to do counting. That's a counting problem. In statistics, there are two types of counting methods, the permutations and then combinations. The difference between the two is that in combinations, we don't care about the order. So for example, what is the number of five card poker hands can you draw from a deck of 52 cards? I do not really care about what order the cards are in, so that would be considered combination. Whereas a permutation, how many two-letter words can you form from 4 letters? So for example, AB, let's say that's a word, AB, and then BA, let's assume also that's a word too, AB and BA. Those would be considered 2 different words. So the order is important. So if that's the case, you do permutation. Typically, the default is combination unless you are otherwise told. Unless it says order is important or something like that, you do combination. And these are the formulas for combination here, and then permutations here. This explanation mark is not yellowing. It stands for factorial, and then you can do that in your calculator. If you look at your calculator, you should have a button for factorial. And this N is the what we call the candidates. So let's say there are 52 cards to pick from, and then R is the slots that you want to fill in. So in this case, 5 cards. So there are 52 cards. N is 52, R is 5, and you plug in the numbers here and you get the answer. So 2598960. That many ways to pull out 5 card poker hands out of 52 cards. Okay. And if you have 4 letters to choose from and then 2-letter words, then the N will be 4 and then R will be 2. So these calculations are pretty cumbersome to do in Excel. So I'll show you how to do that. These calculations are cumbersome to do by hand. So I'll show you how to do those in Excel, which is very fast. So 2 things to remember. If you're doing a combination, the function name is COMBIN. And if you're doing a permutation function, it's PERMUT. And then you put COMBIN and then N first and then R next. So let's go to Excel. So N is, and then R, 52 and then the 5. So let's do combination, which will be COMBIN. And it says number, comma, number chosen. So the number is the N, comma, number chosen is the 5 here. So click on that. You get this answer. Let's do permutation. 4 letters, 2-letter words. Permutation. So this would be permutation. 4, comma, 2. Okay, so there are 12 words you can create from 4 letters and then 2-letter words. Alrighty, so let's move on. You can also scale probabilities. So to show you what I mean, here's an example. Suppose the chance of death due to a heart disease is 632 out of 300,000 people. So if I randomly select 1,000 people, how many of those 1,000 people do you expect to die from heart disease? So what you do is first you figure out the original probability, which is 632 out of 300,000, which is about 0.002103. And then so that's the probability. Then you multiply that by the people you want to learn from. So 1,000 people. So multiply 1,000 times 0.002103, and then round it down to say about 2. Because, for example, we can have 2.1 people. So I expect 2 people to die from heart disease out of 1,000. So that's what you can do to scale probability. And that concludes the lesson on probability.